All right, so first off, monomials. A monomial is a number, just a variable, or numbers and variables put together. So some examples might be 2x, 30, I'm just making some up, 10x squared, y cubed, z to the fourth. Those are all examples of monomials because you are not adding or subtracting anything. And you probably learned some rules about these in Algebra 1. So the first one is the product rule. So I'm going to do like the rule, and then we're going to put an example in. So if I have x to the a power times x to the b power. So I'm multiplying variables. What do I do with the exponents? Add them. So this would be x to the a plus b. So for example, if we have x to the fifth times x cubed, what is that? X to the eighth. 5 and 3. X to the eighth. X to the fifth and x cubed is x to the eighth. Right. The next one is the power rule, which means I have x to the a power, and then that is raised to the b power. So we have an exponent on top of an exponent. What do I do with a and b? Multiply them. This will be a times b. So for example, x to the fifth to the third power is x to the 15th. Perfect. Quotient, that means divide. So the quotient rule is x to the a power divided by x to the b power. Any guesses? Subtract x to the a minus b. So if I do x to the fifth divided by x cubed, this would be x to the second, x squared. Okay. Negative exponents. This one might be a little new. If you have x to the negative a power, to some negative number, that is the same as having 1 over x to the a power. So anytime you have a negative exponent, it moves to the bottom of a fraction and becomes positive. So if I have 3x to the negative fifth power, the number in the front does not move to the bottom. Only what's getting that exponent. This 3 is not being raised to an exponent of negative 5. So the 3 would stay up top, and then the x to the fifth would come to the bottom. And then x to the 0 power. Does anybody know what that would be? It is 1. Anything to the 0 power. If I have 3x to the 4th, y to the 5th, to the 0 power, that's 1. I'm going to show you why that is and why those two rules are. So let's just go over here and do an example. All right. All right, so in your calculator, I want you to type in 3 to the 3rd power. And what do you get? 27. What about 3 squared? 9. What about 3 to the 1st? 3. What's happening to my numbers? From 27 to 9 to 3, what's happening? We're dividing by 3. And notice my exponents are going down each time. So if I continue that pattern, what is 3 divided by 3? 1. That's why 3 to the 0 power is 1. A lot of people want to put 0 there. What if I take this 1 and I divide that by 3? You get 1/3. 1 over 3. So notice that's really 1 over 3 to the 1st power. What if I divide that by 3? We get 1/9, which is really 1 over 3 to the 2nd power. And if I went 3 to the negative 3rd, it would be 1 over 27. So that's how those rules come about. So let's do some examples that have multiple of these rules within them. So the first one, we have 5x squared times negative 7x to the 6th. You multiply those coefficients, those numbers in front, you multiply them like normal. Those are not exponents, so they don't follow the rules that we just listed. You just do 5 times negative 7, which is negative 35. And then we have x squared times x to the 6th, which is x to the 8th. We're multiplying variables. Number 2, we need to do this exponent first. So we've got 2 steps. So we are going to raise each thing in the parentheses to a power of 2. So this would be negative 2 to a power of 2, a cubed to a power of 2, and b to a power of 2. So when you square a monomial, you do each part to that power. What is negative 2 squared? Positive 4. And then we would have a to the, no, put those together. A to the 6th. And then just b squared. And then this is still being multiplied by this 8ab to the 9th. Then we multiply 4 times 8. And we get 32. A to the 7th. B to the 11th. If you're ever not sure about your answer, you can go to your calculator and check it. So just put in some random number for A, some random number for B. I like to avoid using 0 and 1. So if we do, let's see, I'm going to store. So I'm going to do 2 store, and then I'm going to get A, 3 store B, and then I'm going to type in negative 2A cubed B squared times 8A B to the 9th. It does take some time, but got a really big number. And then I'm going to do 32 A to the 7th, B to the 11th, and see if they match. And they do. So that's how you know you got it correct. On the ACT, if for some reason you don't know how to do something like this, you can always just pick random numbers for your variables, plug it into your question, and plug it into each of your answer choices to see which one matches. It might take some extra time, but if it gets you a right answer, that's worth it. All right, number 3, we have a division problem. So first we just take 54 divided by 3, which is what? 18. Now our m's, we have m to the 6th over m squared, so we subtract m to the 4th. And this n has a 1 exponent there on the bottom. So if we subtract those, we get n cubed. Questions? Number 4, 2 times 10 is 20k. If I add those 4 and -7, I get -3. But you are not supposed to leave a negative exponent, so it's negative. That means I move it to the bottom. I'm going to make a fraction and move it to the bottom. So 20 over k cubed. Only the part that's getting the exponent moves. Go ahead and try number 5. That one's similar to number 2. Number 5, your final answer should be 150 r to the 7th, s to the 15th. You needed to square this first and then multiply. Number 6, this one we are just distributing, so we're just multiplying 3 times. So this would be negative 10x to the 7th minus 30 x to the 7th y plus 40x to the 8th. So you were multiplying the coefficients. Those are the numbers in front. And then for our variables, you add the exponents. Any questions? Number 7, we have 15 over 24. That does not divide into a whole number, so you just simplify the fraction. You can just go to alpha y equals and type in 15 over 24, and it will simplify it for you. It's 5/8. have x to the negative second, because 10 minus 12 is negative 2. And then we have y. With these types of problems, we really don't leave a fraction as in the front. We just make it one big fraction, similar to how this one is written. So you need to recognize that this x needs to go on the bottom because it has the negative exponent, and the y goes on top. So when I rewrite it, it's going to be 5y on top and then 8x squared on bottom. Because when I write this on bottom, it becomes a positive 2. Now, some other ways that you can think about these problems, you may see it a little different. You may realize that there are 2 more x's on bottom than there are on top. So when you cancel out, you're just left with x squared on bottom. And then you'll realize that there's 1 more y on top. So when you cancel, you're left with 1 on top. And if you can get straight here, that's okay. Number 8, when we have a fraction with an exponent, you raise the numerator and the denominator by that exponent. So this is really 2 to the 4th over c squared to the 4th. And this is times. I don't know why I put an arrow there. Times. And then we would do negative 3 to the 4th, c to the 4th over here. So you raise both of those to the power of 4. This would be 16 over c to the 8th times. What's negative 3 to the 4th power? 81 c to the 4th. Ran out of room. All right, now when I multiply 16 times 81, that's 1,296. And then think of your c's. You have 4 on top and 8 on the bottom. That means there's 4 more on the bottom. So we're going to be left with c to the 4th on the bottom.
Miss Charity.
Yeah.
I need Ethan Medley to come down here for a moment.
Okay.
Please.
So this is one you might want to check your answer if you're not sure, like, might have got this one wrong. Since there's only one variable, I'm just going to use x. And I'm going to say 2 store x. And then 2 over x squared to the 4th times negative 3x to the 4th. And if I do 1296 over x to the 4th, you get the same answer. So that meant, oh, you can't see. That meant that we did it correct. It doesn't really matter what this number is, but if it matches, it's right. Now, a polynomial is when we have multiple monomials and we add and subtract them. So it's just like there's pluses and minuses throughout. Within a polynomial, the highest exponent, so the largest number exponent, that is what we call the degree. So if I'm talking about the degree, it's just a number, and that number is whatever the biggest exponent is. And we always want to write our answer with the exponents in descending order. That means biggest to smallest. Now, polynomials have names based on two things. Number one is their degree, and number two is the number of terms. And you've done this in Algebra 1, so hopefully it comes pretty easy to you. If the degree is 0, that means there's not even an x at all. We call that a constant. If the degree is 1, we say that it is linear. Degree of 2 is a quadratic. That means it has an x squared. If it has x cubed, that is cubic. Four would be quartic. And 5 is quintic. And we typically stop there. Now, number of terms, that's how many monomials are pieced together. So 1 is just a monomial. 2 is a binomial. 3 is a, any guesses? Trinomial. And then after that, we just say a polynomial with whatever number of terms. We quit giving special names. So if it has 5, Miss Johnson? No. Okay, thanks. Bye. So a polynomial with 5 terms, polynomial with 7 terms, or whatever. So back up here to number 9. We're going to use both names. So you're leaving. Yeah. So this one has just an x without an exponent, so the degree is 1. So it is a linear, and then it has 2 terms. So it's a linear binomial. Number 10, what is the degree? What's the highest exponent? 5. So it's a quintic. And then it has 1, 2, 3 terms, which makes it a trinomial. See if you can go down this list and get through number 16. All right, number 11 was a constant monomial. Number 12 is just a cubic polynomial with 4 terms. Number 13, quadratic trinomial. 14, quartic monomial. And then 15 and 16, you could have a wide variety of answers, but the one I gave for 15 was x cubed plus 1. You had to have two terms, and your exponent could not be bigger than 3. You could have also said 12x cubed minus 7x. That's fine. You could have more than one x as long as your highest exponent was 3. And then number 16, basically you had to have just an x or any number with an x. Can't have a plus or minus anything. Any questions? We're going to do these two examples and then we will stop for today. So adding and subtracting polynomials. Basically, when it's addition, it's just combining like terms. You basically can just drop the parentheses. What I like to do is I like to stack my two polynomials so that my like terms are on top of each other. And I also like to make sure that I'm going in the standard order as I write it down. So if I start with 3x squared plus 11x plus 4, and then I'm going to write these underneath, but making sure my like terms are on top of each other. So my negative 5x I have to write here because those are like terms. Plus x squared, that's 1x squared, and then minus 13. And then we just add straight down. So this would be 4x squared plus 6x minus 9. When it is subtracting, you need to first distribute the negative. So basically, I'm going to turn this into a plus and then change all of these signs. So you start at the plus, or start at the minus, change it to a plus, and then change all of the signs after that. And then it becomes a problem just like 17. Turns into addition. So we have 5x cubed minus 2x squared. I'm going to leave a space for just the plain x because my first one didn't have it. Plus 4. And I want to make sure that I have a place for it when I write my second one down. So then we have negative 2x squared minus 2x minus 17. And because I turn this into an addition problem, I can just add straight down. So we get 5x cubed minus 4x squared minus 2x minus 13. Any questions? All right, we will stop there.